As machine learning plays an important part in artificial intelligence, let's understand a bit better what is machine learning. What is machine learning? So machine learning is a typical way to solve problems where, in order to obtain an answer, we interrogate models instead of the reality. And these models have been built for that purpose. One way of building the model is through using a human expert. And the second way of building a model is by using machine learning. This means that we have typically a huge amount of data, and this data has been transformed through machine learning algorithms into models which are just crunchier and easier to manipulate objects than just the huge amount of data. There are two big families of learning. One is called supervised learning and one is called unsupervised learning. In supervised learning, a first task is the task of classification. I just want to obtain an answer, yes or no, red or blue, and 1 or 0. Typically, in the example which is here, I have got some pupils that have got each an age, that like school or not, that live in a country, and I am trying to predict if they like sports or not. I have got two examples, Alicia and Bob, and one likes sports, the other one doesn't. And from those two examples, but in reality I would have not two examples, but hundreds, thousands, or even hundreds of thousands of examples, I will build a rule or a set of rules. There are many algorithms that will allow to learn different types of rules. But the idea is that then I can use this classifier to take a new pupil called Carlo, and based on his age, based on what we know about him liking or not school, the country he is in, I will want to predict if he likes sport or not. This is then called classification. I could, instead of trying to just predict yes or no, predict a number, predict a value, perhaps predict a grade in the case of Alicia, Bob and Carlo. So again, I have got some data, Alicia and Bob, for which I know what their outcome is. I know their grade in mathematics and for both of them. But now I would like to predict the grade in mathematics for a new pupil, for Carlo. So Carlo has an age of 10. He likes school and he's in Italy. Is there a way of predicting his grade? Again, you can notice that this is a problem for which there may be various answers. And in fact, these answers will depend on the model we are building. So there are many, many different algorithms to do this. One common feature here is that there is no outstanding algorithm in machine learning. There are many different ones, and some would be better suited in certain cases and others in another. Unsupervised learning. Unsupervised learning is, as opposed to supervised learning, a case where the data from which we are learning doesn't have a known label. We don't know in advance a value associated to each element, and so we have to somehow reorganize the data more than obtain a value from them. A typical setting is called clustering. In clustering, we are given data, we are given a way to measure a similarity. This is called a distance. We need to be able to say that some data is closer to another than to a third one. Then we're given a number, because we are being told to build a given number of groups, and the goal is to split the data into groups in which all the elements of the group are close to each other, and on the other hand, the elements from one group are far away from elements of another group. Let's consider an easy example. You are a teacher, you have a classroom, you have your pupils that are ready to do an activity, and you decide that you would like to have groups where the children are all of a similar level. So you use a clustering algorithm to have as many groups as you may have tables and then organize your activity. As you notice, I have highlighted the word decided. because it is not the clustering algorithm itself that is to blame if it was a wrong decision to put people of the same level in the same group. This is, of course, a pedagogical decision, which will probably be very well suited in certain cases, but perhaps not in another. So like with all these algorithms in artificial intelligence, we want to understand the purpose of the algorithm before using it for an educational setting. So here is a set of techniques called reinforcement learning, which is neither supervised nor unsupervised. It is more active in the sense that the algorithm itself is going to produce in different ways the examples it needs to learn, typically through reinforcement, which means that every time the algorithm builds a solution, it will test the solution, and it will either obtain a positive reinforcement because the solution is producing good results, or a negative reinforcement because the solution is perhaps not producing the same results. These techniques have been used with a lot of success in the well-known algorithms that have been beating the best human players at the game of chess and Go over the years 2015 and 2016.